You've learned about containers. You've learned how to create containers using Docker. Now it's time to go ahead and create our own container of our own custom applications. So before we get started with that, I'm just going to give you a brief overview of everything that we're going to do within this video. In this video, I'm going to create a very simple React application using create React app, if you're familiar with that. And then I'm going to put that into a Docker container. This process is pretty simple, but if your applications get more and more complicated, if you have environment variables and everything, it might get a little more complicated as well. I will show you how to set environment variables as well, and I will show you how to give secret keys as well within your containers. I'm also going to show you how to reduce the size of your final containers and how you can make your container usable by pretty much everyone. So let's go ahead and get started with that. So the very first thing I want to do is I want to create a very simple React application using npx, and then we'll go in there and open that in VS Code and then do our further processes. So in order to create the simple React application, all I will do is I will do npx create React app, and let's just call it as demo app. Alright, so here we are within our demo React application. Now, before I even go ahead and get started with creating the whole Docker process, first let's try and figure out how this application is working. So this is an application built in Node.js. Now, if you've worked with React before, you know exactly how to get this app up and running. There are two things which you need to do for running any sort of Node application. Step one is do npm install or npm CI and install all of the dependencies. Step two is running any sort of scripts, either for populating the data of your web application or any other processes. And step three is doing an npm start. Over here, I'm only going to do an npm start. I will not do an npm install because the previous step which I did, npx create React application, that has already installed all of the node modules which I require for this sample application. So all I have to do is do an npm start, and my application should start running on localhost 3000. So let me quickly open localhost 3000 in the browser just to make sure that it's running. And here you can see that the sample React application is running in my browser on localhost 3000. Awesome, great. Now let me close this, and let me close this production server as well. Now I just said production, right? If you're actually going to run this application on some sort of a server, you're not going to just run an npm start. No. What you're going to do instead is you're going to create a build of this application. Once you create a build, that will create an executable file of this particular app. That executable file is what you will run on your production server. So let's create the build really quickly. So all we have to do is do an npm run build. Give it a minute and it will create the build file. All right, we've got the build file created. Now this is the build file of this particular React application. And in order to run the actual thing, all we have to do is these two things: npm install -g serve and serve -s build. All right, that will run this particular build application, which is ready for build. Great, that's clear. Now, what does any of this have to do with Docker? Let's go ahead and talk about that. Now I've gotten rid of the build folder, and why I did that will start making sense to you once we start talking about the Docker process. We want to create a container of this application. For that, we need to first define certain steps on how to create that container. So for that, I'm going to make a new file and call it as a Dockerfile. You don't necessarily have to call it as a Dockerfile. You can call it whatever you want, but the Docker file is the default name. If you don't call it a Docker file, when you actually go ahead and build the container, you'll have to specify the exact name of the file. By default, the Docker CLI will look for a file called as a Docker file. All right, awesome. Now that we have the Docker file, we have a completely empty container. This container has got absolutely nothing inside it. So first thing which we need to do is we need to give it a base on which it can work. You can't exactly work on a computer without having an operating system on it, can you? So similarly, we need to give this container a base with which it can work. So let's just say from node latest. Now what exactly is this node latest? For that, let's head over to Docker Hub. So node is simply an existing container which has Node.js and all of the runtimes which are required for that. So this is our minimal image. This is what we'll use for actually building our entire application within the container. There is one more important option which you need to keep in mind. Now Docker creates containers. These containers are expected to run on a variety of different hardware architectures. It could be either on x86, so your regular Intel or AMD CPU. It could be on ARM. It could be on MacBooks, M1 chips, or the older Darwin generation, etc. Now, in order to make sure that your container is running on the correct platform, you want to pass in a flag. This flag is going to be dash dash platform equal to, and we want to call this current as the Linux AMD 64 as a base platform. And this entire option about which platform you're mentioning has to come before you define your image as such. And you see the error which we had earlier, that's gone. So over here, I'm simply saying that the container which I'm building is supposed to run on Linux x86 architecture or a 64-bit architecture. Next thing which we want to do is we want to set our working directory. So for that, I will do a working directory and I will set a path to it. So let's call it /app. So /app is our working directory. This entire Node.js application, we will put that inside /app. So /app is becoming the root of the project. Now, next step which we want to do is we want to copy this entire source code into our container. So to copy all of the source code, we'll do copy dot and we'll give it a destination which is going to be /app/ because /app is our working directory, right? So all of this entire source code will exist inside this directory called as app. Now, in case you don't want to copy everything that exists and you just want to copy individual files, what you can do is instead of dot, you can give brackets, and you see the autocomplete is already saying what you have to do. So just mention the individual file names. For example, one could be package.json and then all of the other file names. That's a tedious process, so I'm just going to do a dot and copy everything. Now, as a best practice, after you have your application inside, you want to get all of your node modules. So you want to get all the dependencies. So we're going to run the command. We will do a run npm install, or rather instead of npm install, let's run npm ci. So it gets the exact and accurate versions of every single dependency package. The next thing which we want to do is we want to expose the correct port. So earlier when we ran the application locally, not in a container, just locally, we saw that it was running on port 3000, right? So you want to expose port 3000. Okay, let's do that. We've exposed port 3000. Right now, this entire application is going to be run as a root. So inside the container, you will have a root user, and this application will be running as root. Now, I hope I do not have to tell you about the security risks of that. So for that, we are going to assign a user called as node to this particular application. So this application will run as user node. So first, let's run a chown. This will change the permission of /app directory. we'll do a /r node, which node is our user, and we'll tell it that /app. Now ch owns -r. -r is simply recursive. So we're just saying that everything that is under /app, make every single one of those files owned by this user called as node. And then we'll assign node as the user who's running everything inside this container. So for that, we'll do user node. And finally, we can go ahead and start this entire application. So I can do a cmd, and my command is npm start. Okay, so my initial Docker file is ready. I don't want this to be my final Docker file, but this is the very basic version of the Docker file which you can create. We're going to go ahead and do some more optimizations as well. Now you might have a question. Earlier I told you that we usually go ahead and make a build, right? We do an npm build, but we haven't done that over here. We'll do an npm build when we talk about optimizing this Docker file. But for now, let's go ahead and build this Docker file. So in order to build this Docker file, our command is going to be docker build -t. -t simply means that we want an image with a particular file name. So let's call this as a React demo. And finally, we'll put a dot. The dot simply means that the Docker file which it needs to use for building this particular image is located in this current folder. So my folder is called as demo app, and I am in this folder right now. So I will just put dot. If my Docker file was located somewhere else, I would put that whole relative path. If you're on Linux, you might need to give it sudo permissions as well. So simply before the command, just append sudo and you can build it out. So let's go ahead and build this. Now this whole build process might take a little bit of time, so just be a little patient and you can see the entire process that's happening. And if there's any error, it will give you the error. And then you have to figure out what the error is and how to solve it. Now this whole build process has completed. It took me around 15 minutes, but that is because I have weak hardware to begin with and I had a couple of background processes running as well. Depending on your hardware, this might take you as little as 1 to 2 minutes. Before I go ahead and show you the actual image that is created, let's take a look at all of the steps which have happened. So first step is it downloaded the node image. We mentioned the latest node image, right, as a base image. So that's what it did first. This is the process that took maximum amount of time. Then second step was setting the working directory as /app, then copying the source code, this React application code, into that directory, running the npm CI command to install the node modules, the node dependencies, finally changing the app permissions, and that's all. The rest which is there about exposing the ports, selecting the users, and running the npm start command, that will happen when we actually run the image. So let me go ahead and show you the image that was just created. So we can do a docker image list, and you can see that we have the React demo app. Now we can go ahead and run this container. So we can do docker run React demo. It should run since we have the image locally itself. Let's take a look. There you can see it's starting the application. Let's just give it a couple of seconds to start. Then we can go over to localhost 3000 and make sure that it's working. Okay, here you can see that the app has successfully compiled and it's running on the browser as well. Now, if you paid close attention to when we listed out the image, you would have noticed that there is one very big problem that we have right now. So let me list out the images once again and let's see if you can spot the problem. So over here, the biggest problem which we have is the size of the image. It's a 2 GB image. Now 2 GB is quite a big image. this opens up a lot of problems as well. First of all, you have a lot of security issues. Second thing, you have performance issues as well. You have a lot of bloat in this application basically. So we're going to look at how we can fix this problem and reduce the image size. First, let's go ahead and delete the running container. So we'll do a docker container ps, then we'll do a docker container kill, and we'll copy this container ID and we'll get rid of this container. And let's do another docker container ps, and it's gone. All right, so now let's talk about how we can reduce the size of the image. So in order to reduce the image size, let's first understand what we can do. So first thing is we can reduce node. The node binary itself, right now we have a bloated version of it. So instead of this bloated version, we can use a lightweight version of that. Second thing, once we run npm CI, we have the node modules. Now, if you've worked with node modules, you know how heavy those are. So we can get rid of that as well. If we are getting rid of the node modules, now reducing the size of this image by getting rid of the node modules, that is where npm build comes into the picture. So we're getting rid of the node modules, but that won't matter because we have already created a build. The build already has every single component which we are going to require for running the application. So let's go ahead and create a multi-stage build for this. So first things first, I'm going to set this step right here as a build. So this is my build stage. This is where I'm going to build out the entire application. So let's change up a few things here. Instead of doing a command npm start, I'm going to run an npm build. This will generate my build file. So this right here, everything that we are doing here, this is the very first stage of our build. This is where we're actually going to build the whole application, get the dependencies, get the source code, etc. Now in the second stage, I'm again going to start from here, but let me just copy paste this line. Now there are a few things which I'm going to change over here. The stage, first of all, is going to be my deployment stage. And instead of using the latest node image, I will use the Alpine node image. Alpine is basically a lightweight image of node. It's not just node which has an Alpine version of its image. Any single image such as Ubuntu, maybe Golang, all of them have an Alpine version, which is a super lightweight version. So let's first go ahead and copy this build folder, which was created in the first stage, into the second stage. So we'll do copy from build, and we want to copy the build folder, which will be in /app/build, and we want to copy it to a /app within the second stage. So let's set the working directory in the second stage as well to /app, and we will have copied this build here. Now in order to run this, if you remember earlier when we actually built this folder, it told us that we need the serve package, right? So you can see here we need to install first the serve package, and then serve-s build is going to be the command which will actually run the build. So let's just copy paste those into the Dockerfile within our second stage. So once we have copied the app, we need to run an npm install -g serve, and the command which is actually going to execute is going to be serve-s and build. Now this should generate a pretty optimized Docker image for us. Now before I go ahead and do that, let me just tell you about environment variables. Now this particular app doesn't really need any sort of an environment variable. If you had an application which had environment variables, within development you would have a .env folder inside which you would have all your environment variables. You can either copy that using the copy command, but that is pretty insecure, I would say. So instead, you have this command called as environment. So just put an environment and key values. For example, I can say something like dev environment, and the value for that can be something like production, right? So that's one type of environment variable. Now your environment variable will depend on your application itself. I'm going to remove it since this application doesn't really need any environment variables. Cool. Now let's go ahead and build this once again. So I can do a docker build -t, and this time let's call the image as React app optimized. And let's run that and see what the new size of the image will be. Okay, I made one slight error within the Dockerfile. The command which I passed was npm build. That's the wrong command. What I actually need to put in is npm run build. Now this should work. Alright, so our optimized build process has also completed. Now let's take a look at the size of the image. So we'll do a docker image list. And you can see that the original one was almost 2 gigabytes. The optimized one is just 162 megabytes. That's such a huge difference. We can probably bring it down to 2 digits as well using some more build stages, but I'm going to leave that for now because that will be dependent on your specific application. If it's a Go application, then I think you can bring it down to even a single digit megabytes, which is super highly optimized. But yes, this Node application, we're just going to leave it at 162 MB. Cool. So now you have seen how to build a container for your own custom applications. You've also seen how to optimize the image. Now let's look at how you can share it with other people. Now, in order to share it, you need to first put the image onto a container registry. We're going to put the container image on Docker Hub. So once you're logged into Docker Hub, you can come into repositories and you can create a new repository. I'm just going to call this as React app. In order to first push this image to Docker Hub, we're going to want to first tag the image. So first let's list out the name of our images. So Docker image list. Now we want to tag this React app optimized, and the tag is going to be that we want to push it to my particular repository. So we can do that with docker tag React app optimized, and let's call it latest. And then we'll give it the repository name, which is this. And the tag name will again be latest. Okay. Now we simply need to go ahead and push it. So we can do it with docker push repository name, and let's call it latest. Now this particular image, the optimized image, has been pushed to Docker Hub. Let's take a look at that. So here I am back in my Docker Hub repository, and let's just refresh the page and we should be able to see the image. So right there we have the image. Now if you want some friends to go ahead and use this image, they can simply do docker run and pass in this as the whole image name. Awesome. So in this video, you've learned how to create your own custom container of a custom application. You learned how to optimize it, and you also learned how to push the image to Docker Hub. Now feel free to go ahead and make some images of your own custom applications, whatever your applications are. Maybe it's a to-do list, maybe something else, and push it to Docker Hub, push it to GitHub, and you can play around with it.